Happy day to all. This is Selvam from National Vidyalaya Senior Secondary School, Kumbakonam. We are celebrating Max Week from July 27th to July 31st. First day we celebrate numbers. First we will learn about patterns. Patterns all around us. What is pattern? Any idea about it? No? Let's see. What is pattern? Something that keeps repeating. We will see first one is numbers pattern. Numbers pattern is a pattern or sequence in a series of numbers. The pattern generally establishes a common relationship between all the numbers. For example, 0, 5, 10, 15, 20, 25. Here we get the numbers in the pattern by counting by 5. Next one is geometric pattern. Geometric pattern is a kind of pattern formed of geometric shapes and typically repeated like a wallpaper design. For example, see the circle, triangle, circle, triangle, circle, triangle, circle. This is a geometric pattern. Next one is patterns in nature. Patterns in nature are visible regularities of form found in the natural world. The nature patterns include symmetries, trees, spirals, metas, waves, forms, tessellations, cracks, and stripes. First one is symmetries. Symmetry is variously defined as proportion, perfect or harmonious proportions, and a structure that allows an object to be divided into parts of an equal shape and size. See, animals and birds often show mirror or bilateral symmetry. Like this tiger and peacock is an example of bilateral symmetry, and fivefold symmetry, the example of starfish and midler. Next one is trees. All the branches of tree at the every stage of height when put together all equal to thickness and the trunk. This is bamboo tree. This is branching look like a pattern. And leaf, parsley leaf, cow parsley leaf. This is 2, 3 and so on. It's not a infinite, right? Then spiral are common in plants and some animals. Bighorn sheep is look like a spiral shape in the horn, and polythaxis also spiral. Next one is special patterns. The first one we will see about the Pascal triangles. Pascal triangles. One of the most interesting numbers pattern is Pascal triangle. He is a philosopher and French mathematician. To build a triangle, start with 1 at the top, then continue placing numbers below it in the triangular pattern. Here I have highlighted the 1 plus 3 equal to 4, 3 plus 3 equal to 6. This is a Pascal triangle. Patterns with the triangle. First diagonals. The first diagonal is of course just once only. This is pattern. Then second diagonal has the counting numbers 1, 2, 3, 4, etc. The third diagonal has the triangular numbers 1, 3, 6, 10, 15, 21 and so on. The fourth diagonal not highlighted has the tetradical numbers 1, 4, 10, 20, 35 and so on. Then symmetrical. The triangle also is symmetrical. The numbers on the left side have identical matching numbers on the right side like a mirror image. Next, horizontal sums. What do you note about the horizontal sum? The double each time. For example, 1 is equal to 2 power 0. Next 2 is equal to 2 power 1. Next 4 it is equal to 2 square. Next 8 it is equal to 2 power 3. Exponents of 11. Each line is also powers of 11. 11 power 0 equal to 1. 11 power 1 equal to 11. 11 power 2 equal to 1 to 1. 11 power 3 is equal to 1, 3, 3, 1 and so on. Next one is square. For the second diagonal, the square of numbers equal to the sum of the numbers next to it and below both of these. For example, 4 squared equal to 6 plus 10, 3 squared equal to 3 plus 6, 5 squared equal to 10 plus 15. Next, add and evens. If you color the add and even numbers, you end up with a pattern the same as Sierpinski triangle. See, look like this is a Sierpinski triangle. Next one is Pascal. Using Pascal triangle in probability, heads and tails using, for example, I toss one coin, the outcome is head or tail. The coin is tossed twice, the outcome is 4, 1, 2, 1. The coin is tossed thrice, the outcome is 8, 1, 3, 3, 1. Next, polynomial. Pascal triangle can also show you the coefficients in binomial expansion. In power 2, x plus 1 whole squared equal to x squared plus 2x plus 1. Here the numbers represent as the Pascal triangle 1, 2, 1. Next one interesting is Fibonacci sequence. Fibonacci sequence is a series of numbers. See, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34 is a Fibonacci sequence numbers. The numbers formed by adding up two numbers before it. The 2 is found by adding the two numbers before it, 1 plus 1. The number 3 is found by adding the two numbers before it, 1 plus 2. The number 5 is found by adding two numbers before it, 2 plus 3, and so on. Fibonacci sequence. Pascal triangle form a Fibonacci sequence also. See, 1, 1, 2, 3, 5, 8, 13, 21, and so on. Make a spiral. When we make squares with those widths, we get a nice spiral. This is a golden ratio. Golden ratio is a special number approximately equal to 1.618. It appears many times in geometry, art, architecture, and other areas. It is a Greek letter pi. There is a special relationship between golden ratio and Fibonacci sequence. Now I will get two numbers a and b. Here a is 2 and b is 3. We divide b by a is equal to 1.5. Next we will get a equal to 3, 5, b equal to 5. We divided by 5 by 3 equal to 1.6, and so on. It will come a golden ratio 1.618. Then golden ratio and Fibonacci sequence in natures. The nature represent as a Fibonacci sequence or golden ratios. First, plants. Plants petals are representing Fibonacci number. See, white lily look 1 petal, Europhia 2 petals, Trillium 3 petals, Columbian 5 petals, and so on. This is look like a nature. Then seeds heads. Sunflower seed heads. 55 is the 10th Fibonacci number. 34 is the 9th Fibonacci number. We divided 55 by 34, will get the golden ratio. It's same as the pine cone and pineapple also. The many of the nature represent the golden ratio or Fibonacci sequence. Shell, tiger, butterfly, satin, hand, human ear, human face, all of them represent the Fibonacci ratio or golden ratio. Fibonacci day. Fibonacci day is November 23rd as it has the digits 11, 23. Here 1, 1. 11 is a November month. 2, 3 is represent the day 23rd, which is the part of the sequence. So coming November 23rd, let everyone know the Fibonacci day. I know all of you enjoying today. I will give one assignment to find out the series of numbers from Pascal triangles. Thank you to all.